Welcome folks. In this video we are going to look at the mathematics paper 2. Now we'll focus on section B and we're just going to look at the two questions, question 8 and 10. Then question 10 is about statistics, where we can see that our first question here, question A, is we want to calculate the standard deviation. Now standard deviation tells us how scattered the data are from the mean value. Now let's not focus into definition. The focus on thing is, first we need to look at what type of data are we dealing with. So we are dealing with what we call the group T data. Then for some of you that may face troubles when identifying the type of data that you have, you just have to look at this. If you are given intervals like 0 less than x less than or equal to 10, whenever you are given this kind of interval, just know that you are dealing with a group T data. So this is a grouped data that we are dealing with. Now for ungrouped data, we only have individual numbers. So like 2, 3, 4, 5, 6, if you have those numbers, remember that it is ungrouped data. Now I want us first we focus on finding the same standard deviation minus without forming a table. So first we'll begin by finding the mean. So the mean formula is just the summation of f of x. So we need to find f. We know f is just the frequency here. Then x is the midpoint. I'll show you how to find the midpoint. Then over the total of the frequency. Then from there we'll proceed to calculate the standard deviation. So the formula for the standard deviation, if you are not using a table, the formula is summation of f of x squared over summation of f minus mean squared. So this is the formula that we are going to use. So for the formula, we are going first to begin by finding mean. Then from there we'll proceed by finding the expression of summation of f of x squared over f of x. Then we'll proceed by finding our standard deviation. Now let's begin by finding the midpoint. So the midpoint, what you do is you add these numbers. 0 plus 10 is 10. You divide by 2, which is 5. So this means that our midpoint is 5. Then here you add 10 plus 20 is 30. Divided by 2, we have 15. That is our x here. Then 20 plus 30 is 50. Divided by 2, we get 25. Then here 30 plus 40, 70. Divided by 2, 35. 40 plus 50 is 90. 90 divided by 2, we get 45. 50 plus 60 is 110. Divided by 2, we get 55. 60 plus 70 is 130. Divided by 2 is 65. So this is how to calculate the midpoint. You need to add the two numbers from the interval, then you divide by 2. Now after we have this information, we can now proceed to finding our mean. So let's look at mean. So mean is equal to, we have this summation. So we're not going to write the summation. We'll first begin by write our f. F times the first midpoint is 5 plus f frequency times 15 plus f times 25 plus f times 35 plus f 45 f 55 plus f 65 over the total frequency. So the total frequency will be 3 plus 18 plus 14 plus 22 plus 23, another 22, then 8. Then after reaching here, we are now going to substitute where there is f. So the first midpoint is 5. This 5 corresponds to the frequency of 3. So this will be 3 times 5 plus here is 8. So this is 8 times 15 plus 14 here, multiplied by 25, plus 22 times 35 plus 23, we'll go with 45, plus 22, we'll go with 55, plus 8 times 65 over the total frequency. So the total frequencies we just have to add 3 plus 8 plus 14 plus 22 plus 23 plus 22 plus 8. So my total is just 100 here. Now let's look at the upper. We'll focus on the upper for now. So we'll just do the mathematics. So 3 times 5 is 15, plus 8 times 15, I'm getting 120, plus 14 times 25, 350, plus 22 times 35, 770, plus 23 times 45, so 1035, plus 22 times 55, 1210, plus 8 times 65, 520. Then we divide by 100. Now let's find the total. We can add. So 15 plus 120 plus 350 plus 770 plus 1035 plus 1210 plus 520. So my total of f of x is 4020 over 1000, over 100. So if we divide by 100, I'm getting 40.2 as my mean. So we are done finding the mean. So let's go back to the formula. So now we need to find this expression here. So we'll begin by that. So we have summation of f of x squared over summation of f. So here the formula, we can see that it's frequency times x squared. So the only difference with the mean, the midpoint is not squared, but under this one we are going to square the midpoint. So let's go back to so that we can see the numbers. So the frequency we have 3, 8, 14, 22. Okay, so let's go back now. So this will be frequency. Okay, let's begin with the frequency times our first midpoint is 5 squared plus frequency 15 squared, then 25 squared, 35 squared plus 45 squared plus 55 squared plus 65 squared over, we know the total is just 100. Now before substituting the frequency, first I will just first expand these numbers. So 5 times 5 will give us 25 plus then 15 squared will give us 225, then plus 25 squared give us 625, plus 35 squared 1225, plus 45 squared 2025, plus 55 squared 3025, plus 65 squared 4225 over the frequency is still 100. So that is the difference between the mean and this expression. We just have to square the midpoint. Now let's go back to our first frequency. So the first frequency is 3. So we can now go back. So this will be 3 times 25 plus then what's our second frequency? 8. So 8 times 225 plus 14 625 plus after 14 what do we have? 22. So 22 with 1225. After 22 what do we have? 23. So 23 will go with 2025 plus 22. So 22 will go with 3025 plus the last one is just 8 there, we'll go with 4225 over the same total, which is 100. So we can see that it may look very long, but the all stages or process that are involved are just very simple. So let's now do the multiplication and we add. So we have 3 times 25, we get 25 here, plus 8 times 225, 1800, plus 14 times 625, 8000, 8750, plus 22 times 1225. So 22 times 1225, I'm getting 26,950, plus 23 times 2025, I'm getting 46,575, plus 22 times 30, 25, 66,550, plus 8 times 4225, 33,800 over 100. So let's add. We have 75 plus 1800 plus C 8750 plus C 26950 plus C 46575 plus C 66550 plus C 33800. So according to my calculator, I'm getting a 184,500 over 100. So we'll see that our final answer, we'll just cancel this, will be 1,845. So we have that expression. So now we can finalize our final answer. So we know that now standard deviation is equal to the square root of summation of f of x squared over summation of f of x minus mean squared. So this expression, this expression we have found, the answer is this. So this will be 1845 minus the mean we calculated mean to be, what does 40.2. So 40.2 squared. So what is the 40.2 squared? So according to my calculations, I'm getting 1616.04. Then we subtract this number from the other number. So I'm getting 28.96. Then what is the square root of this number? 228.96. So I'm getting 15.12, three significant figures. So this is our standard deviations. Now let's move on to question B. Now, using the table above, copy and complete the cumulative frequency table below. So we just want to sorry, that's the paper that I'm using. Someone wrote these numbers, but anyway, we'll see what we can do. So how do we complete provided these numbers are not there? So what you do is you need to add. So you say 0 plus 3. So you add plus 3, you get 3. 3 plus 8, you get 11. 11 plus 14, you get 25. 25 plus 22, you get 47 here. Then 47 plus 23, you get 70. 70 plus 22, you get 92. 92 plus 8, you get 100. So this is how we complete the table. And remember, this table must be on the graph paper. Now we can now look at the Roman number 2, using a scale of 2 centimeters to represent 10 units on both axes. For the range under the axis, the x-axis, the range is 0 up to 70. Then for the y is 0 up to 100. Draw a smooth cumulative frequency curve. So let's see how we can draw this. So we are going to draw a vertical line. Please make sure you use a rule. So this is our x-axis. Now in the x-axis, we know it's height, and our height is in centimeters. Then what is our y-axis? So y-axis is just the frequency. So it's the frequency, or we can say the total number. Now let's first begin. So the first point that we are going to plot is 0,0, and we know where there is 0,0 is just the origin here. This is where our 0,0 is. Then the next point is 10,3. 10,3. Oh, I forgot to put number. So this is 10, 20, 30, 40, 50, 60. Then we have our 70. Even here we are going to use 10 since we are told for both axes. Now under the y-axis we are supposed to reach up to 100. Okay, so we have the numbers now. Before we start plotting, maybe let's do this. We know that it's 2 centimeters to represent 10 units on both axes. So we'll say the same 10 units you divide by 10. Always you divide by 10. So 10 into 10, it's 1. So this means that these smaller boxes each represent 1. So that's what it means. It's 1. So 10,3 under the x is 10, then y is 3. So you just go on the 10, then you add 3 more small boxes. So 1, 2, 3. 10,3 is here. Then the other one is this one, 20,11. So 20,11, 10 is here, so you just add 1, 11 is here. Then we move on to 30,25, 30,25, 30,25. So 30, then 1, 2, 3, 4, 5. 25 is here. Then we go to 40,47. 40,47. So 40,47. 1, 2, 3, 4, 5, 6, 7 here. Then here we have 50,70. So 50,70. Okay, so 50,70. So 50,70 is here. Okay, then after 50,70, what you have? So 60,92. So 60,92. So if this is 50, 60,92 is here. 92 is here. Then the last one, 70,100. So we go 70,100 is here. Then we can now draw a smooth cumulative frequency curve. Make sure you draw it as smooth as possible. So that question that we are told to draw a smooth cumulative frequency curve, we are done. Now let's look at Roman number 3. Under Roman number 3, showing your method clearly, use your graph to estimate the semi-interquartile range. Semi-interquartile range. So for us to find the semi-interquartile range, we need to find the quartile 3 and quartile 1. Then we find the average of the difference. So let's first begin by finding quartile 3. So quartile 3 is Q3 is equal to 3 over 4 times the cumulative frequency. So the cumulative frequency is the highest number in the y-axis where the graph is reaching, so which is 100. So what is 3/4 of 100 will give us 75. So 75 is not our final answer. We need to go in the y-axis. Then we need to look at where there is that 75. So 75 we have 1, 2, 3, 4, 5. So 75 is here. Then we are going to draw a line parallel to the x-axis until it touches the curve. Then from there we need to turn 90 degrees. This time we'll move parallel to the y-axis. So parallel to the y-axis. Make sure you also use a rule here for accuracy. So you can see that it's at this point where we are touching the x-axis. So this is what our final answer. So if this is 50, if we add one small box, this is 51. So our quartile 3 is 51 since it's height centimeters. Then let's also look at quartile 1. Q1 is equal to, it's 1 over 4 multiplied by cumulative frequency, 1 over 4 over the same number 100. So this will give us 25. So we'll do the same. We need to go in the y-axis, so where there is 25. So 1, 2, 3, 4, 5. 25 is here. We are going to do the same. So you draw a dotted line. Then here. For this question, we can see that we are just getting the actual number. So quartile 1 is equal to 30 centimeters as our height. Then let's find our final answer. Now our final answer, quartile 3 is 51 centimeters minus 30 centimeters over 2. 51 minus 30 will give us 21 centimeters over 2. 21 divided by 2 will give us 10.5 centimeters. So this is our semi-interquartile range. So this is what we can say about this. Now let's go to question number 8. So question 8a, answer this part of the question on a sheet of graph paper. The variables x and y are connected by the equation y is equal to have those. Some corresponding values of x and y are shown in the table below. Then for the first one, calculate the value of k. So first we need to write the equation. So the equation is y is equal to x minus 3, then x minus 5, x plus 2. So k, we can see that k is under the y values. So we substitute where there is y, we put k. Then x, you need to, for you to substitute the value of x, you need to get the number of x value that is corresponding to k, and the number is 6. So it will be 6 minus 3, 6 minus 5, 6 plus 2. 6 minus 3 will give us 3. 6 minus this one will give us 1. Here will give us, we'll have 8. 8 times 3, the value of k is giving me 18. So we have our value of k, which is 18. Now Roman number 2, using a scale of 2 centimeters to represent 1 unit on the x-axis for the range -2 up to +6, and a scale of 2 centimeters represent 10 units on the y-axis for the range. Draw the graph of, okay, so let's look at this question here. So here we are going to draw this line, our xy plane here. So x here, y here. So let's look at the range. For x is -2 to +6. So we have -2 to +6. And we know it's 1 centimeter representing, 2 centimeters representing 1. So this is 1. Then here 2, 3, 4, 5. So our 6, just extend this line. So my 6 is here. So I was supposed to push this line for the y coordinate to the left side, but okay, we can manage it for now. So here will be -1, here -2. So that's why the best way is first, before you draw the line, the xy plane line, make sure you plan so that it fits. Then for the y is -10 to +40. So it's -10 here, -20. We can add. Then what else? So we have 10, 20, 30. We have our 40. Now, before we start plotting, first let's look at in the x-axis. So in x-axis, we know it's 2 centimeters represent 1, so it's 1 divided by 10. So we know that now if the smaller boxes each represent 0.1. Now in y-axis it's 10 units, so 10 over 10, which is 1. Okay, so we have this information. We can now proceed. So begin. The first one is -2, 0. -2, 0 is just here. This is where -2, 0 is. The second one, -1,24. -1,24. So -1,24, 21, 22, 23, 24 is here. Then what else? We have 0,30. 0,30 is here. Sorry, the 30 is here. So 0,30 is there. Then we go to 1,24. Positive 1,24. So 1, 2, 3, 4 here. Then we have 2,12. 2,12. 10, 11, 12 is here. Then 3,0. 3,0 is here. Then we go to 4,-6. 4,-6. So 4,-6. So -1, 2, 3, 4, 5, -6 is here. Then we have 5,0. 5,0 is here. Then we have 6, k is 18. 6,18. So 18, 1, 2, 3, 4, 5, 6, 7, 8. So we can now draw our line. So this is the original equation is x minus 3, x minus 5, then x plus 2. So we have our graph. Now let's move on to question Roman number 2. Use your graph to estimate the gradient of the curve at a point -1, 24. -1, 24, -1, 24 is this. So you can draw a straight line, which is a tangent that will pass through that point here. Now remember, if you are using this concept is the -1, 24, we'll consider this is as our x1, y1. So for us to use the actual formula, we need to find the x2 and the y2. So we can get any point within the tangent. Our answer will always be the same. So it depends on your drawing, but for me, I will get it from here, because I know that to get x, I'll just get -2. Then to get y, it is 10. So these are my x2 and y2. So let's find the gradient. So the gradient this time will be, so gradient is equal to y2 minus y1 over x2 minus x1. So y2 is 10 minus 24 over x2. x2 is -2 minus -1. So 10 minus -24 is -14 over here. We know that this negative will add, so give us -2 plus 1. So it's -14 over -1. Gradient is equal to +14. So this is how you can find the gradient if you are using the coordinate form. Now let's say we introduce the calculus. So how can we find because the calculus is one way that will give us the actual gradient. These are just estimations, and calculus, the differential part of calculus will give us the the gradient of a curve at a given point. So we know that the equation is y is equal to x minus 3, then x minus 5, we have x plus 2. So we need first to expand for us to use calculus, since we have been given a factorized one. So say x times x, we have x squared. X times -5, we have -5x. -3 times that is -3x. -3 times -5, we get +15. First of whenever you are expanding 3 brackets, first you begin with 2. Then here we can see that we can add these two. So -5x minus 3x will give us -80x plus 15 is equal to x plus 2. Then we can expand. So x squared times x will give us x to the cube. X squared times 2 will give us 2x. -8x times x will give us -8x squared. Then x times 2 will give us -16x. We go to 15. 15 times x will give us positive 15x. 15 times 2 will give us 30. Okay, so here we are going to have x raised to the power 3 minus 8x squared, 2x, and these 3 are this should be squared. Okay, this should be, because it's x squared times 2, so this b should squared. So 2x squared minus 8x squared will give us -6x squared. Negative 16x plus 15 will give us negative x plus 30. Now we are going to find the first derivative, so dy over dx. So we move 3 to the front, so this becomes 3x raised to the power, we subtract 1 squared. Then here 2 times negative 6 will give us negative 12x. 2 minus 1 is 1, minus here, whenever you have x raised to the power 1, the differential of that one is just 1. Then the derivative of a constant is 0. Then where there is dy over dx, we put in m. Remember, the pair of our coordinates that we are given were negative 1, 24. So the x is negative 1. Whenever you are trying to find the gradient using the calculus format, make sure you use the x value. So where there is x, we'll put the x value. So here we know that negative 1 squared is positive 1 times 3, we have 3. Negative times negative, we have positive 12 minus 1. So 3 plus 12 will give us 15 minus 1. Here we have 14. So by using calculus, the gradient is 14. By also using the coordinate form, we are also getting 14. But the explanation for this is that calculus will give you the exact gradient of a curve. But for this one, these are just estimation. Now, since under mathematics here, we know that there is, with the introduction of calculus, you can use the derivative to find the gradient if you want. They consider all these to be correct. So we move on to area bounded by the curve x negative 1. So let's look at where there is x negative 1. So x negative 1 is this line here. This is our x negative 1 as our boundary. Then what other boundary do you have? X positive 2. So x positive 2 is this one here. Then what else? y0. y0 is the y-axis, the x-axis. So we can shade. This is the area that we want. So let's consider this box here. So we can see that if we are to remove one box, we can see that under the y value, we said it's 2 centimeters represent 10 units. Then in the x is 1. So even if this is a square, and the square is considered to have 4 same length, here we'll consider this one, the longest one, as our L, the shortest as our breadth. So we'll just consider this shape as a rectangle. So area of a rectangle is equal to L times B. So area, what's our L? 10 times 1. So area is equal to 10 times 1 will give us 10 units. So for a complete square has 10 units. So let's look at how many complete squares we have. So we have 1, 2 here, 3 here, 4 here, 5. Then let's do this. So we can see that here this is not complete, this is not complete. So we'll get this box here, we'll just get it, we'll divide it to just complete this. Since these are estimation, we'll just use it. So we'll consider we have 1, 2, 3, 4, 5, 6, 7. So we'll say now area, total area is equal to 7 times 10 units. It's squared. So our approximation area is 70 units squared. Remember, the question is use the graph to estimate. It is an estimate. So you may find an answer that is different from mine. My point is, as long as you've followed the correct steps, then you will be considered to be part of. So that is what I just wanted to share with you guys for this video. So that's it for this video. Thanks for watching.